Hello viewers, today I'd like to present a geometric proof of the simple algebraic equation or identity a plus b times a minus b is equal to a squared minus b squared. Okay, let's first draw a square whose side length is a. So that's a square whose side length is a, right? Then let's draw another square whose side length is b and place it inside the square. For the sake of simplicity, I presume that b is less than a, right? So we are trying to place the other square at such that the center of both the squares meet, meaning the point of meeting of these two diagonals, or the midpoints of these four sides. That's what I call the center of the square, right? And the center of the other square of side length b So this is a square of side length b such that their centers match. That is, both the diagonals meet at the same point. Now, this width, because it's exactly at the center, this difference is a minus b, right? This difference, if I said this were x, then this would also be x, because the smaller square is seated exactly at the center of the larger square. The center of the smaller square is seated exactly at the center of the larger square. So this would be symmetric, right? Similarly, this gap would also be x, and this would be x as well. So let's say we joined this way, right? So what we have here, let's say this is A, B, C, D. Let's call this P, Q, R, S, right? So what we have here is a quadrilateral A, P, Q, B, which is a trapezium because this side and this side are parallel and the other two sides are not. AB is parallel to PQ, but AP is not parallel to BQ. Therefore, this would be a trapezium, right? So I'll draw it out here separately, like this. So this is A, B, Q, B. This is the length A, this is the length B, and this is the height of the trapezium, the distance between the parallel sides, which is x. Just cut this out of here and redrawn it here. Now we find that x plus b, x plus b plus x is this a, that is x plus x plus b plus x. This is x, this is b plus x. That's equal to the side length of the largest square, which is a. Or in other words, twice x is a minus b, or x would be half of a minus b, right? Now we have four such identical trapeziums here because this is exactly symmetric, right? A, B, Q, P, B, Q, R, C, S, R, C, D, A, P, S, D. These are four identical trapeziums. They are exactly the same because this figure is totally symmetric. So we could look at the area of the largest square ABCD, area of square ABCD. This can be written as the area of the smaller square, area of square PQRS, right? This one, plus the area of these four trapeziums, right? Four identical trapeziums. So we could write that as 4 times the area of trapezium ABQP, right? The area of the largest square is going to be the square of its side length, that is A times A, which will be equal to the area of the smaller square is the square of its side length, which is B times B, plus the area of this trapezium. The area of the trapezium is given by the area of this trapezium is half the distance between the parallel sides, which is x, into sum of the lengths of the parallel sides, which is A plus B. This is the area of this figure, right? But there are 4 such identical trapeziums, so 4 times half of x into A plus B from here, because that's the area of this trapezium alone. There are 4 such identical trapeziums, 1, 2, 3, 4, right? So this means A squared is equal to B squared plus, this is 4 divided by 2 is 2, times x is half of A minus B from here, times A plus B, and 2 and this 2 will get cancelled, right? We subtract B squared from both sides, we get A squared minus B squared is equal to B squared minus B squared plus A plus B into A minus B. B squared and B squared, they get cancelled, or in other words, A plus B into A minus B is A squared minus B squared. This is the result that we are looking for. Hope you like this geometrical interpretation of this algebraic identity. Thanks for watching. Subscribe to our channel and enjoy. Thanks.